Hello and welcome in. Mark here, aka the Markster. This is video number 29. Number 29 in the FreeCAD series. Today we're going to be looking at more of the tools in the part menu and the part workbench. We're going to look at these copy tools, and also we'll talk about this part container object and probably a few more things. Let me show you which version of FreeCAD we have here. Is 0.19 19694 revision number. I'm on Windows 10. This is a development version. So in the last video we went down through the part menu here and looked at some things that we hadn't looked at yet. We talked about these mesh tools here, the box selection and reverse shapes. So you might want to go back and watch that one if you haven't watched the previous video yet. Not that this really follows, not that it really builds upon anything that was in there. And we'll hopefully look at this attachment tool also. And once we're finished with that, we'll be pretty much finished with the part workbench. We'll be coming back to it, but we can start moving on to part design. So the first thing let's do is let's look at these copy tools, and we'll compare these four tools. So let me add something on here that would copy. Cylinder should work. We'll select the cylinder, create a copy. Let's create a simple copy. So the simple copy has none of the radius and height properties. It's just a basic object. It's non-parametric, and what that means is whatever changes you make to the original will not be, it won't change this copy. So you have a copy, like a snapshot of that object at the time when you made it, and that's it. Now let's look at the next one that we'll look at is the refined copy. So let's fuse these two together, and we'll select the fusion object and go to create the refined shape copy. And I'll move this one over a bit so we can see the differences. So we see the refined copy has removed these extraneous line edges. Now we've done this before with the refined property in the fusion object, which by default is set to true, but I have mine set to false in the settings. For one thing, these lines can come in handy during modeling, so I like to have these lines available. And then when I'm finished, if I want it to look a little nicer, I can do the refine. So this gives us a copy that is parametric to the original. So if we were to go in here and let's say make this cylinder a little bit wider, more radius, you see our parametric copy also changed with it. If we go to the dependency graph, we see that Fusion 01, which is the refined copy, there's an arrow pointing to Fusion, so it's a dependent of Fusion. It's a little bit unusual for dependents. Most of the time they'll capture parents, I think is what it's called, where you'll have this expansion and collapsing tree here. But you can see visually that the fusion depends on these two parent objects. But with the fusion object, you don't get that. So it could be a little bit confusing, but it is a parametric copy. Now, in earlier versions of FreeCAD, it was not a parametric copy. It was a simple copy that was refined. And let's see what the other copies we have. We have the create transform copy and create shape element copy. So let's tackle the transform copy, I guess. To understand it, we're going to need to know about this object here, which is a part container. So the part container can act as an object that can contain other objects. So I dragged and dropped the fusion into the part container. Now if you open and close, you can see better which objects are contained within it. Sometimes it can be confusing, so is it in the object or is it not? It can be confusing. Let's take a look at the dependency graph now. And we see that the part container is this green shaded area. It has an origin object with some sub-objects in there. And it has the fusion and the refined copy and the fusion and the two child elements, parent elements actually. So we can see what's in the part container and what's not, which the cylinder 01 here is not. That was a simple copy of the cylinder. So now let's look at this origin object. I'm going to make it visible. And what we're seeing here are the sub-elements within this within this origin. So we have the XY plane, the XZ plane, the YZ plane. You can map sketches to these planes, which we'll do more of when we get to part design. So what the part object is used for is usually in assemblies where you can have multiple objects that are related to one another, and you'll be able to move the entire section at a time rather than moving each individual part, each individual component. So an example of this might be an automobile. You have a model of an automobile, and maybe a subassembly would be the engine, and then maybe subassemblies of that would be like the alternator maybe. So we could have another part within a part. So you can have parts within parts within parts, as many as you like. And what this would enable you to do, maybe your alternator, the bracket it connects to the engine block with the pulleys, things of that sort. You might elect to have those as a sub-assembly, so then you can pull all that off without having to get each bolt individually and move it. You can just move the entire alternator assembly or sub-assembly, and that's kind of what all this is for. So each part object provides what you could call a local coordinate system to the objects contained within it. And we can move the part object through its placement property. You can right click on it and choose transform and move the entire thing all at once. And if we toggle the axis cross in the view menu here, this axis cross is at it's a global coordinate system origin 0, 0, 0. Each of these objects here are at the global coordinate system, the local coordinate system, provided by the part object that are containing them. So the fusion object, you can see its placement is shown as 0 here, but it's obviously not at 0 here at the global coordinate system. It's 0 to the part's local coordinate system. Hopefully I'm explaining this properly. So let's get back now to this copy tool. Create a transform copy. So first let's create a simple copy of this fusion object. So you see it, put it back here at the origin, and its placement is all zeros, and it's at the origin. If I drag and drop it into this part, it appears here because this part is still on the origin where it was created at within this part. So it's a container within a container. Okay, so if I want to move this part, I can move it. And if I want to move the parent part, I can move the entire assembly. So now let's make a copy of this fusion, a transform copy. Create transform copy. Okay, it did not appear here. It appeared there, but it's not in the part. It's not in the part container. See, when I collapse the part tree here, it's not in that part container, but it's located at that location. When you look at its placement property, you see that it's not zeros. So the difference between the simple copy was that it appeared here at the origin, and the transform copy appeared at the location of the original, but not in that container. Now if I drag and drop it into it, then it's out here further. So that's the difference between the transform copy and the regular simple copy. It must be within a part container for that to matter. If it's not within a part container, you're going to get the same results with a simple copy and with the transform copy. So it's only related to objects within part containers. And now let's look at the shape element copy. So when you select an object in FreeCAD, the first click in the 3D view, it selects the object in the tree, and for operations that involve the entire object, that works fine. But you can also do operations on the sub-object or sub-element, which there are 3 types. We have faces, we have edges, and we have vertices. So if you want to make a copy of a sub-element, such as a face, you can do it with this tool here, the Create Shape Element Copy. So now we have a copy of that face. And we can do things with that face that we've been doing already, like extruded or loft or sweep or whatever. So if we wanted to extend this shape in this direction, one option we could have would be to create a shape element copy of this face and then extrude it. Let's select the object first, which you can do here within the dialog. Or if you wanted this shape of this face here, you could copy it as well, the same way. So now we have just that face. This works okay, but it's not parametric. Let's look at the getting ever crowded dependency graph. You see that extrude 3 is that face we just made. It's not connected to anything. Extrude 2 is connected to extrude 1. That was that face that we just extruded. We see our two parts, two part containers, each a different color. So this works okay, except it's not parametric, which is kind of a deal breaker. But in some cases, you know, you can use it. But there's another tool in the draft workbench that I'll show you that you can use, and it is parametric. It does the same thing. So let's go to the draft workbench, and this is called a face binder. So if I select this face and click the face binder tool, I now get a face binder. I don't know why it made the other object invisible. Oh, probably because it's in another part or something. I'm just going to close this document and start another one. Now let's go back to draft, select this face, use the face binder tool, which is also in, which are these, the drafting menu right here. We'll select this face binder, go back to part, now let's look at the dependency graph, and you see the face binder is linked to the box, so it's parametrically linked. It doesn't take it as a child. Grab children, I think it's called. Claim children, I think. Anyway, that's in the code. It's another one of those that doesn't claim children, but it is parametrically linked to that object. So if we made a change to this cube, let's see, yeah, if we made this face wider, that shape binder changes with it. So you have a nice parametric linking there. This parametricity works pretty well. I have seen times when I want to say it didn't work perfectly. So, you know, sometimes it works perfectly, sometimes not, possibly. Could be I did something wrong too at the time, but I seem to remember having some issues with it at one point. But it's parametric, and it's a pretty good tool to use at times. And on the subject of making copies, so we have the different types of copies that I showed here. In the create a copy menu, you can also copy something by right clicking and choose the link action here. Make a link to the object. Now let's move this cube and see what happens to the link. So the link moved with it. No, it didn't. The extrude moved with it, but the link did not. But if we change the width, you see the link responds to it. And we'll look at the dependency graph here. We see that the link has an arrow pointing to the original box. I don't know if this is technically a copy or just a link to the same object, and it's being displayed in a different location. Difference there would be some greater efficiency without having to actually create those objects. You just show another representation of it. But don't quote me on that. Might be wrong about that part. Another copy that we can make is in the draft menu, draft workbench. It's a clone here. It's the cross-eyed sheep. So let's make a clone of that fusion. A clone of the extrude, excuse me. And let's move it up. So I'm moving the extrude object upwards. And the clone remained where it was. So the clones and the links remain where they are when you move the original. There are so many objects here, I'm losing track of which one's which. The clone has some capabilities of scaling, which you can also do with the link. The link has a scale option right here. So we can make the link twice the size of the original. There's the original cube, and there's a link. The clone can also be scaled, but individually along the X, Y, and Z directions. So if we only want to scale it in the Z direction, we can get that. Or we can go smaller. Another thing that the clone gives you is the ability to attach. The original object might not be attachable, but the clone can be. Let me discard these changes, make a new document. And let's just fuse these two together. And we'll add another cylinder. And let's move it out here. Okay, so if we wanted to attach this fusion object to the cylinder, we can't do it because the fusion object is not attachable. But we can make a clone of it, hide the original, and now we can attach the clone to that cylinder. And when we move that cylinder, the fusion object will move with it. Because it's attached. If we look at the dependency graph here, we see that the clone is attached to both of these. And fusion object is still in its original location. Another option that we have, let me hide the clone and show the original. If we want to attach this fusion object to that cylinder, we can use the tool in the part workbench at the bottom here, the attachment tool. So let's select the fusion object, come down and select the attachment. So even though this fusion object is not attachable, we can still attach it using this tool here, but it will not be parametric. So you see fusion is not attachable. You can still use attachment editor dialog to align the object, but the attachment won't be parametric. So what that means is, yeah, we can align it with it and attach it to it, but once we move the cylinder, it's not going to move with it. So it's more of just a temporary attachment. We got it lined up, but that's all we did, which would have been okay if it's in one of those part containers and we just want to get it lined up together. We just want to get that bolt into that alternator, right? And they're going to be in the same part container, so later we can just move the entire assembly or entire sub-assembly and it'll still be in that right location. So I think I've covered what I was wanting to cover in here. Hopefully some of it's going to stick. Hopefully I didn't make too many mistakes. Some of this, I don't fully understand it entirely myself. I just have a kind of a basic understanding. And that can be useful just to have a basic understanding, because then when you're doing a model or something and you need to do some task, and if you think back and say, oh, I think we can do that with the clone, then at least you have an idea of where to go, what to do, and then do a little more research on the cloning and how to use it. But you'll have an idea of a starting point, at least pointing you in the right direction. So hopefully this little quick overviews are beneficial, as opposed to just starting with a model, making a model, and covering what comes up during making of the model. I'm not sure which video type most watchers would prefer, but I think I'm trying to do a combination of both of those, because it's useful to see start to finish, and it's also useful sometimes just to zero in on particular features and how to use them rather than just making a model to show off how to use it. So anyway, that's going to be it for today. We're going to start looking at part design later on. I've covered pretty much everything has been covered, at least briefly. But we'll be still working in part workbench from time to time. It's just we're going to start looking at part design upcoming. I'm not sure if that'll be the next video or not, but we'll start looking at that next. So once again, thank you for watching, and as always, have a great day.